You're listening to the CyberLex Leadership Podcast, the home of serious CISA learners and future audit leaders. If you want more than memorization, if you want to think, reason, and operate like a true IS auditor, this is where serious auditors are made. In CISA Domain 4, everything begins with one deceptively simple concept: IT components. Not the systems themselves, but the relationships between them. Today's scenario reveals the danger of running a critical system that everyone depends on, but nobody truly understands. This is episode 23, the system everybody used, but no one fully understood. IT components seem basic: servers, storage, networks, interfaces, databases, but CISA uses them to test your understanding of architecture, dependencies, and failure impact. CISA questions often hide the key clue. A system fails, but no one knows which component caused it. This reveals 4 exam themes: lack of documentation, undefined ownership, weak architecture understanding, missing dependency mapping. CISA is checking whether you think beyond the single system and ask, what supports it? What connects to it? What fails with it? What risks propagate through it? This is the mindset of an audit leader, not a checklist auditor. You're auditing a system called Mercury, used by finance, operations, customer support, compliance. Everyone relies on it. Everyone assumes someone else understands it. During a routine outage review, Mercury goes down for 47 minutes. Operations restarts it. It comes back. Everything looks fine. You ask, what component failed? Silence. You ask, who owns Mercury? 3 teams point at each other. You ask, where is the architecture diagram? Nobody knows if one exists. You start investigating and discover Mercury runs on an old VM cluster. It pulls data from 2 shadow databases. It authenticates with an outdated lightweight directory access protocol instance. It depends on a file share that IT stopped maintaining last year. A hard-coded IP address exists in the config. Mercury is stable only by accident. It is connected to components nobody actively manages. It is critical but fragile. You realize? This isn't a system outage. This is architecture debt exposed. A junior auditor might say, the outage was short, no big issue. The system was restored, so risk is low. Monitoring didn't show major errors. They evaluate the event, not the architecture. They assume systems are simple, standalone, and self-contained. But CISA and real audits require you to ask, what components make this system work? Which ones failed? Which ones are unmanaged? Juniors stop at symptoms. Leaders look for causes. Audit leaders approach the situation differently. They immediately evaluate. 1. Component inventory. Does the organization know servers, storage, network paths, dependent services, authentication sources, databases, API integrations? 2. Ownership and accountability. Who supports each component? Who approves changes? Who maintains documentation? 3. Architecture documentation. Are diagrams accurate, kept updated, aligned with reality? 4. Dependency mapping. What fails if Mercury fails? What fails if a supporting system fails? 5. Technical debt exposure. Old configs, shadow systems, deprecated components. 6. Monitoring coverage. Are all components monitored, or just the main application? Leaders evaluate the system as an ecosystem, not an isolated box. CISA uses IT components to test whether you think end-to-end, understand dependencies, evaluate architecture risk, identify missing documentation, detect ownership gaps, differentiate symptoms versus systemic issues. Wrong choices in the exam usually look like restart the system, review application logs only, ask the system owner for more details when none exists, increase monitoring. Correct CISA reasoning focuses on identifying component dependencies, reviewing architecture documentation, verifying ownership and responsibility, understanding how failures propagate, Evaluating monitoring coverage. This is where strong candidates separate from the rest. A strong IS auditor gathers architecture diagrams actual, not theoretical, inventory of all supporting components, configurations referencing external systems, network flows, authentication sources, application programming interface and interface documentation, ownership matrices, responsible, accountable, consulted, informed, incident history, change management for supporting components, monitoring dashboards for each layer. This is real audit work, the work that earns credibility with IT leadership. The risk is not the 47-minute outage. The real risk is unknown dependencies, no ownership, no documentation, technical debt, unmonitored supporting systems, hidden single points of failure. A system is only as strong as the components that keep it alive. If you don't know what those components are, you don't have a system. You have an accident that works. You've just sharpened your audit judgment, and that's how serious auditors are made. For deeper mastery, explore the CISA Gold Standard series on Amazon. We don't just help you pass, we help you become someone the field can rely on.